Good morning. So section 5.1 begins a chapter where we're not dealing with polynomials or square root functions. We're dealing with things like logarithms, exponentials, and like 2 to the x. Well, that would be an exponential. Different types of equations, and we're going to learn how to do their derivatives and learn how to do their integrals. And these properties will all be given to you. These derivative and integral properties will be given on the test. But it's great because here at the end of the year, it's going back and it's reviewing derivative rules. Like we'll do quotient rule and product rule again and chain rule again. So section 5.1, the natural logarithmic function, will focus on differentiation. If you want to look at page 318, I'm not going to do this, but you could look through and make sure you remember the things about the natural log function that you're supposed to. And I'll just do a couple of properties, like this is on the bottom of page 319, theorem 5.2. The natural log of 1, I'll just review you of what this would be equal to. And I got this off Pinterest a long time ago. And first off, though, remember natural log has a base of e, Euler's number, which is a irrational number like pi, 2.718 forever. So it's irrational, it never repeats, never terminates, and it's the base of the natural log function. So a logarithm asks a question, e to what power is 1. So that's what this question right here is asking. E to what power is 1? Well, e to the 0 power would be 1. But you could also get it by the inverse of a logarithm is an exponential. So we could take this and write it. I do this swoop. I got that off Pinterest. To e to the what power is 1. So you just fill in the exponential with the order that you draw your swoop. And ask me about this if this doesn't make sense. So what power do we raise e to get a 1? We raise it to a 0. So, and then property 2 is important, the natural log of the product. Remember, a product can be rewritten as a sum, so that's ln A plus ln B. Property 3 at the bottom of page 319 is the quotient. Well, property 3 is the power, which is really important, and property 4 is the quotient. So you use these in algebra or pre-cal and algebra 2 when you rewrote logarithms and expanded and condensed. And if you turn the page to page 320, example 1 has got you doing some expanding of logarithms. Look at example 1 on your own. Just remind yourself of how those work. And then it talks about e on page 321. And you could ignore the integral definition for now. And you could just look down at example 2 and maybe just plug a few of those in your calculator and make sure you get the right answers. And then we're picking up on page 322. We have 2 derivative rules. And I'd say one is more handy than the other. The first one is the derivative of the natural log of x with respect to x. And this answer is just 1 over x, as long as x is greater than 0. We don't do anything with this. This is just keeping it legal. We can't take the natural log of a negative. So there we go. And I'd say this one is more handy. The derivative of the natural log of u with respect to x is 1 over u times u prime. So 1 over u times the derivative of u. And again, u must be greater than 0. I say property 2 is more useful because it's not really often that you're just going to be taking the natural log of just a simple x. It does happen. It's going to happen today, but not as often as it's the natural log of some quantity that we have to deal with. Okay, so let's see how these work. I think you'll like these. They're a really straightforward use of those two rules. So example A, what's the derivative of 3x with respect to x? Oh, sorry, I left off the natural log. What's the derivative of the natural log of 3x with respect to x? Oh, we want to take the natural log of something other than just a simple x, so that's our u. We don't do anything other than to realize that's the u. So we jump right into the rule that it's 1 over u times u prime. So it's 1 over 3x times, and maybe right above u I'll do just the derivative. The derivative of 3x is 3. So 1 over 3x times 3. Put it over 1. Let those 3's reduce out. And our answer is 1 over x. B part. What's the derivative of the natural log of x squared plus 1 with respect to x? Again, this is the natural log of something, so that's our u. You don't have to read it, I'm just doing that for us. So the answer is 1 over u times the derivative of u, which is 2x. And then you would just put it all together as 2x over x squared plus 1. And just remember, you cannot divide these out because this is part of the sum down here. All right, let's do another. C, what's the derivative of the natural log of x ln of x with respect to x? Oh, sorry. I guess I'm out of practice or something. What's the derivative of x ln of x with respect to x? All right, this is our u, and we want to take the derivative of this, and we need to notice that this is a product. So we're going to have to do product rule. So as we go to take our derivative, it's still 1 over u. But when we do the u prime, derivative of that denominator, it's product rule. So it's first, derivative of second, new rule, plus second, derivative of first. All that can go over 1. So you can get, well, let's simplify this a little bit. Those x's are going to reduce out and be just 1 plus ln of x over x ln of x. All right, let's do D part. The derivative of parenthesis ln of x close parenthesis cubed with respect to x. Okay. So we are wanting to take the derivative of this, and when we go to take the derivative of that, we're going to do chain rule. So when we, it's something to a power, so it would be, the power would come to the front, it would be 3 times the something to the 1 less power times the derivative of the inside part, which is 1 over x. So that was a big chain rule problem involving natural log. So if you put this all over 1, you'd get 3 parenthesis ln of x squared all over x. Alrighty, we're going to do example 2. Differentiate f of x equals natural log the square root of x plus 1. So we could do this the way we were doing the others, but can we rewrite using logarithm properties, specifically the product, quotient, or power properties? We can rewrite this before we get going as x plus 1 to the 1/2. And then the power property says the power can come down in front of the logarithm. So that would be 1/2 natural log x plus 1. All we've done is rewrite using properties. So now we're ready to do a derivative. So the derivative would be the constant times the derivative of this, which is 1 over u times u prime. Now make them all fractions. The numerator is just a 1, and the denominator is 2 times x plus 1. Okay? Log properties are very handy. You're going to want to probably rewrite the logarithm using the properties, expand it as much as you can, and then do the derivative. That's really why we learned those properties last year, or in Algebra 2, because it's handy for us now. It wasn't handy for us last year. All we learned was how to do it, but we're like, well, that's fun. But we didn't really see where it was going to benefit us until this year. It's going to assist us in taking derivatives. Just look at this natural log problem. X, parenthesis, x squared plus 1, all squared, over the square root of 2x cubed minus 1. Ooh, we would not want to jump in and do 1 over u times the derivative of that complicated quotient with a product mixed in. That would be very messy. So what we want to do instead is rewrite using log properties. So let's do natural log. Let's first take care of this product here. Rewrite it as a sum. And then minus the log of the denominator. And then the last thing we would do is expand a little bit more and take the powers down to the front. Don't forget the square roots of 1/2 power. So you got ln of x plus 2 ln x squared plus 1 minus 1/2 ln 2x cubed minus 1. Now we did a lot of expanding, and I think you'll agree that that looks nicer than what we started with, because now we can just take the derivative of each of these little pieces, which should be pretty nice. So the first one, derivative ln of x, that's that first rule that I said didn't happen very often, but sometimes it does. It's just 1 over x. Plus 2 times the derivative of this, which is 1 over u, times u prime, minus 1/2 times the derivative of this, which is 1 over 2x cubed minus 1, times 6x squared, u prime. We're going to erase right up at the top, so I'm on the same screen. So the derivative is 1 over x. Make all these fractions down here so you can look all the way across and get plus 4x over x squared plus 1. Make everything a fraction. I'm going to go ahead and reduce the 2 and the 6 for a 3 on the top. Minus 3x to the third over 2x cubed minus 1. All right. That's as far as we're going to go for today. Now I think you'd be ready to tackle the problems that I assigned to you for Monday. All right, good luck, and I'll see you Wednesday.